So let's solve this question. This question was asked in GATE 2006. Okay. The question is, there are three processes with process ID 0, 1 and 2. Okay. With burst time given as 2, 4 and 8 units respectively. So you see, these processes are P0, P1 and P2 and their burst time are 2, 4 and 8 units respectively. Arrival time of all these processes are 0. Here you see arrival time of all these processes are 0. So we have to use LRTF, longest remaining time first algorithm, and here you see the condition is mentioned in the question. Ties are broken. Ties are broken means what? If more than one process have the same burst time left, then there is a tie. So CPU should be given to which process? Okay, so there should be a tiebreaker. Okay, so ties are broken by giving priority to process with lowest ID. So here the process with lowest ID will be given the priority. So ultimately we have to find out the average turnaround time. Okay, so here priority is given on the basis of process ID because here arrival times are same. If there would have been different arrival times and in the question if they would have not been mentioned about how to break the tie, then what you have to do? Then on that time you should give the priority to the process which arrived early. Okay. So but here you see arrival times are all equal. So now in order to break the tie, we will use process ID. Fine. And moreover, it is given in the question. So just solve it using longest remaining time first algorithm. So since I have already explained you LRTF algorithm in the previous video, so here I will not take it longer. I will finish it soon. Just you see. Here I will solve it very quickly. Let's draw the Gantt chart. Okay. You see at time 0 seconds, all the three processes have arrived. Means what? How many available processes at time 0 second? P0, P1 and P2. Okay. So since we are using LRTF, longest remaining, so we have to select the process with longest burst time. So here P2 will be selected because P2 has the longest burst time. So you see, if P2 will run for 4 seconds, you see, from 0 to 4 seconds, if P2 will run, okay, so here 8 minus 4, 4. 4 units will be left for P2. Okay, so now you see here, we have three processes available, P0, P1 and P2. So we have to select the process with longer burst time. So here there are two processes with longer burst time. Process P4 has 4 units, process P2 has remaining 4 units. So in order to break this tie, CPU will be given to process P1 because process P1 has the lower process ID. Okay, so here I will write process P1. Fine. Now you see, if process P1 will run for 1 unit from 4 to 5, so 3 units are remaining for process P1. Okay, so now you see, since 3 units are remaining for process P1, now again process P2 has the largest burst time. Okay, so again CPU will be given to process P2. Okay, so now process P2 will run for 1 unit, 5 to 6. So now here 3 units will be remaining for process P2. Now you see again there is a tie between P1 and P2. So now CPU will be given to process P1 to break this tie because it has lower process ID. So again I will write here P1. Okay. So it will run from 6 to 7 units. So now 2 units are left for process P1. Okay. Now CPU will be given to process P2 because it has the largest burst time of 3 units. So here I will write process P2. Okay, it will run for 1 unit, 7 to 8. Fine. So now 2 units are left for process P2. So now you see there is a tie between all the 3 processes. So now CPU will be given to process P0. Why? Because process P0 has the lowest process ID. Okay. So here I will write process P0. Here you see, all the 3 processes have the same burst time. So the largest burst time here is what? 2 units, and 2 units are left for all the 3 processes. So here, in order to break the tie, CPU is given to process P0. Why? Because process P0 has the lowest burst ID, lowest burst time. So process P0 will run for 1 millisecond from 8 to 9. So it has 1 unit left. Okay. Now there is a tie between process P1 and process P2. Both have the largest time. So CPU will be given to process P1 in order to break the tie. So I will write here P1. Process P1 will run for 1 unit from 9 to 10. So 1 is remaining for process P1. And you see now CPU is again given to process, Now you see process P2 has the largest burst time. So CPU will be given to process P2. So here I will again write process P2. Okay. And you see it will run for 1 unit. So now 1 unit is left for process P2. So now you see there is a tie between all these processes P0, P1 and P2. And all these processes have one unit left. So now in order to break this tie, CPU will be given first to process P0. So P0 will run for 1 unit, 11 to 112. So 0 is left. So P0 is done. Okay. Now CPU will be given to process P1. So here 12 to 13. P1 is done. Similarly, at the end, 13 to 14. P2 is also done. So you see how I have drawn this Gantt chart. Okay, it's very simple. It's very simple concept. It's more easier. It's easier than SRTF and round robin. If you have understood those concepts, then LRTF is nothing for you. Okay. So now they have asked to calculate the average turnaround time. So let's calculate the turnaround time of each process. So I am removing this. Here it was 2, 4 and 8. Okay. So let's write the completion time first. After that I will write turnaround time. Okay. So what's the completion time of process P0? 12. Process P1? 13. Yes, and process P2? 14. Okay. And let's calculate the turnaround time. Turnaround time of process P0. What's the formula? Completion time minus arrival time. 12, 13, 14. So that's all about LRTF algorithm. I hope you have clearly understood this concept, and whatever question will come in the examination, you would be surely be able to do it. Okay. Thank you.